And when I'm talking about free radicals, in the convention of the book, in this part, we're talking about the dot. The dot is an extra electron. That's just what the dot means. Sometimes they write dot minus, which indicates that it's conferring a total negative charge to the molecule. Sometimes they just write dot. Sometimes they'll just throw a minus on some molecule, and you're supposed to know that it's stuck an extra electron there for some reason. So, when our dot hops on, when you have a long hydrocarbon chain, especially one that's unsaturated, that dot has a couple of different targets. It can target at the end, right? And if the reason that it might temporarily attach at the end is because simply it's at the end. It has the biggest ability to access that molecule relative, or that part of the molecule relative to the other molecules. So it may try to get this carbon atom. If it tries to get this carbon atom, that's going to fall apart really fast. That carbon atom is going to do everything it can to get rid of that extra electron. Carbon just cannot stand it to the point where it almost won't accept it. Okay? So this is very unstable and highly. And when I say unfavorable, it means that if it's got another option, it usually doesn't do this. Okay. Now I'm going to come all the way over here. We have multiple bonds, but I'm going to come over here just because it's easier. All right, so this carbon has 4 bonds, and this carbon has 4 bonds, but they're sharing. Sharing to a carbon is fine, but not as fine as 4 of its own. All right? So we've got another dot over here. So it can attack a carbon over here. Now, carbon doesn't necessarily just want an extra electron, it wants an extra proton too, right? Carbon would rather be CH, H, H, H. Or, in this case, CH2 attached to another carbon, attached to another carbon. So, but when the electron attaches, it will very quickly bring a proton along with it. Okay, so in this particular case, this is a better target. It's more favorable. But this is the middle of the molecule, and if you look at a phospholipid bilayer, and again, I'm just drawing zigzags, just pretend there's cis configurations in there. These are happening in here, and the CH3 is down here. So when you look at the relative probability of this happening here in the middle versus this happening at the end, 2 things are at play. Where the part of the molecule is and how much it's willing to accept that extra electron. So, okay, more favorable but less accessible. So, this okay. So, going back before I'm going to take a picture of this, but before we do that ROOH transfer of electrons again, if we think back to the adsorbable radical and the way that there were all those different oxygens and it was able to stabilize that electron across all the different oxygens, oxygen's just better at that. It just does a better job at that, and it's more able to take it. So when we go from step 1 to step 2, you can see that the oxygen, we use diatomic oxygen and we make a carboxylic acid instead of the methyl group at the end. That temporarily allows that electron more space to move. That's why the oxygen gets pulled in. That doesn't happen all the time, but in terms of spontaneous reactions or spontaneous resolution of something, this electron is going to do the damage that it does because it hunts around and tries to find a place. Question?
As I was listening to the lecture of Monday, you said that oxygen can only neutralize 1 free radical per molecule. Is that correct?
Oh, okay. So in the adsorbable radical, the adsorbable radical can only take 1 electron at a time.
Okay.
If the adsorbable radical takes 2, then it splits up into adsorbate. Like, in other words, each adsorbable radical takes 1. So 1 adsorbable radical plus 1 adsorbable radical is 2 total electrons, in which case ascorbate and dehydroascorbic acid is formed. The ascorbyl radical will split into, one will give the other electron. Do you want me to draw it? I'll draw it.
And this is when you say that one goes to substrate and another one goes elsewhere?
Yes.
Yes?
Yes, okay, so I'm thinking whether we're talking back about vitamins. So when a substrate is something else, so we may be, do you remember what the specific, was it this one at the end or was it at the beginning? It's okay. We're going to go through this and I'm going to attach vitamin C to this, and then if it jogs your brain as to where it is or the specific question, I'll show you where it goes. And if not, then we'll figure it out. Okay, so I'm going to take a picture of this because I think this is helpful in the background. And then I'm going to draw this.
What does that say right at the top?
This says this electron will bring a proton, an H plus, with it very soon. But of course, then over here, once you break this bond, so now this hydrogen is super, this carbon is super unhappy. So I'll write that, super. It's double bond. So when this one is super unhappy to lose its double bond with this carbon over here, because if you break this, then you've got the extra energy here and it needs a fourth partner, then it's going to try and add its own H. So